Now we can also look at the difference between strong versus weak acids and bases. So let's see some of the specifics with that. There's actually very few strong acids. In fact, there's 6, and guess what? All 6 are located on this slide. Now, to be a strong acid or a strong base means that you have something that's a strong electrolyte. So if you remember, electrolytes are something that's split apart when you put them in water. And so these are things that will separate when you put them in water. They'll form ions, and those ions will carry electrical charges. Well, again, there's very few strong acids. There's 6 of them. So look at these. How many of them are binary acids? How many are oxyacids? Well, it's split in half. We have 3 binary, and we have 3 oxys. And if we look at our binaries, look at the naming. HCl is hydrochloric acid. Remember, with binary, we add the prefix hydro. We change the ending to ic. HBr is hydrobromic acid. HI is hydroiodic acid. Hydro, ic. The oxyacids use the polyatomic ion name. Perchlorate became perchloric acid. Nitrate became nitric acid. And sulfate became sulfuric acid. So make sure to know those naming techniques. Now, what I would probably do is I would probably write these 6 down on my cheat sheet, and I'd say these are the strong acids, and then I would list these 6. Now, your strong bases are metal hydroxides of group 1 and 2A. Metal hydroxides, so we have some sort of a metal, we have some sort of an OH, hydroxide, and these are going to be group 1 and 2A, your alkaline metals and your alkaline earth. Now, this one isn't quite as cut and dry as the strong acids are, but this is the general rule of thumb that we use. So let's see if we can name these. LiOH is, that would be lithium hydroxide. NaOH, well, that's just sodium hydroxide. KOH is potassium hydroxide. CaOH2, so that just means it's something that's in group 2 because it has 2 hydroxides. But remember, when we name it, we don't have to use those Greek prefixes. We just call it calcium hydroxide. And then finally, we have BaOH2, which is barium hydroxide. So those are your strong bases. So we discussed the strong, but what about the weak? Now, weak acids and bases are weak electrolytes. That means that less than 1%, rule of thumb, actually dissociates or break apart, meaning that they would rather stay together as a molecule than they would breaking apart to ions. So for your weak acids, they give some examples. They have acetic, carbonic, nitrous, or any acid not listed as strong. That's the rule I go by. So remember, an acid starts with hydrogen, and if it does not have a, it's not on your strong acid list, it's probably going to be a weak acid. Your weak bases are your molecular bases. And again, ammonia is the only one that we will really talk about. So let's see what happens in a solution with weak versus strong. The first solution is supposed to be a strong acid. So if we look really closely, you can see the light bulbs lit up. And if we can look at the molecular view, we have hydronium ions and we have chloride ions. But everything has been broken apart. There's no HCl still in that solution. It's either H plus or it's Cl minus. In the middle slide, we have a weak acid. This one's acetic acid. And again, if you scroll in really tight to that, to the molecular view, We have mostly the yellow is acetic acid. There's another acetic acid, and another, and another, and another, and another. We have a few acetates. Those are the greens. A few hydroniums, but it would rather stay as acetic acid. It doesn't really want to break apart. Now, kind of funny fact, it turns out that your HCl and your acetic acid will actually react at the same rate. All that we're doing, talking about the difference between weak versus strong, is just what happens when you put them in water. Weak versus strong, and I forgot to mention this earlier, it has no effect on how safe or dangerous these substances are. Some of your weak acids are extremely dangerous, like hydrofluoric acid. If you watch Breaking Bad, that's the acid that they use to dissolve people. It's a nasty acid, but it's considered to be weak because when you put it in water, it forms a weak electrolyte. The last picture is ammonia. So these kind of peachy colored circles, those are ammonia's NH3s. We have a couple of the purple ammoniums where that ammonia has stolen a hydrogen from water, and that's left just a couple of the blue hydroxides. But remember, weak acid, weak base just refers to what happens when you put it in water. Strong electrolytes, strong acids, strong bases completely dissociate. Weak electrolytes would rather stay together.